In this video, we're going to look at rational exponents. So we're going to simplify expressions with rational exponents and solve equations with rational exponents. And what a rational exponent is an exponent over here that is a fraction. You can see I have a numerator and a denominator. And there's two ways that we can write a fractional exponent. Okay, and one is to write it as the dth root of x to the n, and the other way is to write the dth root of x all to the n. Now there's flexibility here. There's flexibility that you can use either one of these formats and you'll still get to the same thing. So we're going to do some simplifying without a calculator. I apologize. This has a multiplication symbol between them. I didn't notice it didn't have that. So I'm actually going to do these two different ways. I'm going to do them with radicals and I'm going to do them with exponents, because radicals and exponents, you're able to use them interchangeably. And just like in the last section, how the exponents, how I could solve a bunch of different ways, I have a lot of flexibility as long as I'm not breaking any of our rules. One with exponents. Right now I have 2 and 2, and that is the same base. So I can just add my exponents. 2 to the 1/2 plus 1/2, and that's 2 to the first, which is just 2. If I had done this with radicals, 2 to the 1/2 is the square root of 2, times another square root of 2, which is square root of 4, which is 2. You can see how I got the same answer, and I just approached it two different ways. Now, 2 to the 1/2 times 8 to the 1/2. If I want to do radicals is actually a little easier, so I'll do that one first. It's square root of 2 times square root of 8, which is square root of 16, which is just 4. Now, if I wanted to do it with exponents, I can rewrite, right now I do not have the same base, but I can rewrite 8 as a power of 2. It's 2 cubed. 2 to the 1/2 times 2 to the 3/2. I'm going to add my exponents. 2 to the 1/2 plus 3/2 is 2 squared, which is 4. So I got the same answer, but you can see how on that problem, doing the radicals was a little bit easier. Okay, so again, a lot of... You gotta just laugh about it. A lot of flexibility here. So 25 to the 3/2. There's two ways you could do this. And just notice, it's telling me to do this without a calculator. So the first way I'm not going to recommend, and that would be doing the square root of 25 cubed. I don't know what 25 cubed is off the top of my head, and I'm even less likely to know what the square root of that is. So what I'm going to do instead is that second format and do the square root of 25 and then cube it. If I'm dealing with smaller numbers, I'm going to be able to evaluate them. Square root of 25 is 5, and 5 cubed is 125. So here, we want to convert between radical and exponential form. So x to the 5/4, well, that is the 4th root of x to the 5th, or 4th root of x to the 5th. You could do either one of those. Cube root of y to the 8th, y to the 8/3. Ooh, this last one's a little spicy. It's got it as a decimal. So the first thing I'm going to do is take that decimal and rewrite it as a fraction. 0.6, well, that's 6/10, which is 3/5. So it's 5th root of z to the 3rd. Okay, so remember all those simplifying we did the other day in class? I'm going to do these the exact same way. I'm going to first notice whether it is adding between them or multiplying between them. These have a multiply between them. So that means I can take this exponent and apply it in to both of those pieces. So I'm going to get 8 to the negative 1/3. And then when I raise powers to powers, I multiply. 15 times negative 1/3. Well, that's negative 15 thirds. So 8 to the negative 1/3. And then this is going to be 15 over 3 is 5. Those both have negative exponents. They're unhappy in the numerator, so they're going to move down to the denominator. And one last thing, 8 to the 1/3. That's really the cube root of 8, which is 2. Ooh, this one's a little bit trickier. I'm going to do the same kind of thing. We're going to take this and apply it into both of them. So we get 16 to the negative 3/4, and then y. Negative 8 multiplied by negative 3/4. Okay, well, the negatives are going to cancel, and I'm left with to the 6th. So the y is happy where it is. It's going to stay there, and then I bring 16 down. Now I need to do the 4th root of 16 and then raise, oh, but it's not negative anymore, I apologize, to the 3rd. 4th root of 16 is 2, cubed is 8. Y to the 6th over 8. Next one. Actually, take a moment, pause the video, and try these too. I know, they're a little spicy. Did you try them? Okay, so what we're going to do is we're going to take this. This is an addition, but I'm distributing a multiplication over addition, not an exponent over addition, so that's okay. So I'm going to distribute this. 4a to the 3/2 plus 1/2 plus a to the 1/2 plus 1/2. 3/2 plus 1/2 is 4/2. 1/2 plus 1/2 is 2/2. So this is 4a squared plus a. Now our strategy for this type, because even though it looks really big and intimidating, our strategy was to split it into two separate fractions. So 9a to the 1/2, b to the negative 1/2, 12a 3/2 minus 6a squared. So do that first. If you haven't already tried it, try it that problem from there. Okay. So 9/12 is 3/4. When I work with these two together, they have the same base. I'm going to subtract the exponents. I'm really going to get a to the 1/2 on the bottom. Then these two, I'm going to flop them for a moment, which will be 3b. Now this one, 6 over 12 is 1/2. A squared over a is a on the top. And then this is going to bring up this 1/2 ab squared. Now the only thing that's a little tricky on this is this one actually is leaving a radical in the denominator. And it gets this kind of funny thing that if you're answering with your exponent rules and the saying that I don't want to leave any negative exponents and I only have one of each piece, sometimes you're actually leaving a radical in the denominator, and that's okay. So because the directions here did not say I had to rationalize, and that's perfectly fine because it didn't say in the directions to rationalize, it just said to simplify. So one last one. Ooh, this one's a little tricky. I'm going to start by rewriting it as 27a b squared to the 4/6. And the reason I'm doing that is because I can simplify 4/6. 4/6 is the same as 2/3. 27. I'm going to do the 27 to the 2/3 over on the side. It's cube root of 27. squared. Cube root of 27 is 3. Squared is 9. So this can apply in 9a to the 2/3, negative 2/3, b to the 4/3. 9b to the 4/3 over a to the 2/3. Again, this is not a rationalized answer. This is leaving it in terms of my exponents. Okay. The next type of thing that we're going to do is some equation solving. Okay. So there's two different types of equation solving we're going to see in this problem, and it's all going to depend on where the variable is. If the exponent contains the variable, we're going to rewrite with common bases simplify and set exponents equal, and then solve the equation. So, to take a look at this, 2 to the x is equal to 1/8. 2 to the x. I'm going to rewrite this as a power of 2. Well, this is like 1 over 2 cubed, because 8 is 2 cubed. And then to get it in the denominator like that, it's really a negative 3. So now that my bases are the same, see how I have my base the same? Then I can set my exponents this equal. So the resulting equation is x equals negative 3. On the one next to it, let's try one that's a little bit trickier. I have 9 to the x plus 1 is equal to the square root of 27. So I'm going to rewrite them both as powers of 3. 9 is 3 squared, and 27 is 3 cubed, but I have this square root, so I'm going to write that as 1/2. When I raise powers to powers, I multiply. Make sure that you distribute that too. And this one like that. Now you can see my base is the same, so I can set my exponents equal. Oh, that was the worst color to pick. Sorry. There we go. Sorry about that. So now 2x plus 2 is equal to 3/2, and I solve that resulting equation. Subtract that. Negative 1/2. Multiply by 1/2 instead of divide by 2, and x is negative 1/4. Okay, so you can actually go back and check these as well. Say 9 to the negative 1/4 plus 1. It's going to be a hot mess. And then square root of 27 is the same hot mess. The second style of problem is if the base contains the variable. In that scenario, we're going to isolate the base, undo the exponent, and solve the equation. So what I mean there by that, to isolate the base, I'm going to divide by 4. To undo the exponent, I'm going to raise to a different power. Now this is right now to the 3/2. I'm going to raise to the reciprocal. I'll raise to the 2/3. My exponents cancel there. I'm left with x. And so basically what I'm doing is I'm squaring and taking the cube root. So this is the cube root of 8, and then I'm squaring it. Cube root of 8 is 2. 2 squared is 4. Boom. All right. We'll try one more. To isolate the first step here, I'm going to add the 2 to the other side. X minus 1 to the negative 1/4 is 2. I'm going to raise this time to the negative 4th. So I want to get rid of that negative exponent as well. So I'm going to do that to both sides. X minus 1 is 1/16. And then add 1. 1 and 1/16 if you like a mixed number. If you like an improper fraction, 17/16. And now here is an application problem. We did these earlier, but now you're going to, so we're going to read it, write the equation, solve it based on those strategies. A house bought 5 years ago for $100,000 was just sold for $135,000. It's the nearest 0.1%. What is the annual growth rate? Okay, so I've got that we bought it for 100,000. Oops.
One time I got rain when I didn't have my rain.
All right, so now 135,000, 1 plus r to the 5th. So we're going to divide to isolate. So this is the undoing exponents. So we divide by 100,000. We get 1.35 is equal to 1 plus r to the 5th. Now the most common mistake right now would be to distribute that 5 in, but we're not allowed to do that because of the addition sign. What I'm going to do instead is I'm going to basically take the 5th root or raise to the 1/5 on both sides. And I have 1 plus r and then 1.35 to the 1/5. Make sure that as you're doing it, your newer calculators probably don't need that, but mine needs a parentheses. 1.062. 1.062 and subtract 1, and then my r is 0.062 or 6.2%. All right, so there is 1, 2, 3 problems left that I would like you to try on your own. Have a wonderful day.